So students, today we are going to discuss about the collision theory. Till now we have come to know that the reactants will change into products, or we can say the reaction will take place only when the reacting molecules are going to collide with one another. Now, the collision theory is also based on it that for a reaction to take place, the molecules of the reactant should collide. Now, the number of the collisions taking place per unit time and per unit volume is known as the collision frequency. So what is the collision frequency? It is the number of the frequency taking place per unit time or per second per unit volume is known as the collision frequency. Now, from the collision theory was given by Max Strauss and William Lewis. So they have just told that the first point will be that the for a reaction to take place, the reactant molecule should collide, right? And the number of collision taking place per second per unit volume is denoted by capital Z, which is known as the collision frequency. Now, students, you can think that when we are taking the reactants in a reaction vessel, so if every collision will form the product, then the rate of the reaction should be very fast. But the reaction rate is not fast as it is expected. Or we can say that the rate of reaction is slow. Right? So what is the cause behind that? It means that every collision is not leading to the product formation. Now, for the product formation to take place, the collision which is taking place, it has to follow two conditions, students. Now, the first condition is the energy barrier. It should overcome the energy barrier. And second is the proper orientation of the molecules before they collide. Now, we are going to discuss here the collision theory. So, according to the collision theory, right, we will first we have discussed just here about the term collision frequency denoted by capital Z. So what it is? It is the number of collision per second per unit volume. Next, we are talking about that to get the product form, it is not only the collision, but it should be an effective collision. We are talking about the word which is the effective collision is required for product formation. Now, which collisions will be known as the effective collisions? So, to have the collision effective, there should be overcoming of the energy barrier, and second is the proper orientation of the reactant molecules. Right? Now we are going to discuss them one by one. Now let's start with the energy barrier at first. Now students, the energy barrier means that the reactant molecule should possess the minimum energy, right, before it undergo the product formation, right? So before it undergo the product formation, it should have the minimum energy. So here we will first discuss the energy barrier. So here, for the effective collision, the reactant molecule should possess minimum energy to form the product. Now here, not let to get any confusion here, let me write here the reactant molecule should possess, let's come to the directly to the term here, should possess the threshold energy. So should possess threshold energy. Now comes what is the threshold energy? Now it is the minimum energy required by the reactant to form the product. Right? If the reactant will possess the threshold energy, right? This much amount of energy, if it will be possessed, then only the reactant will be converted into the product. Right? So I'm just drawing here a graph to just show you that how it is can be expressed. Now here it is the reaction rate, the progress of reaction. This is students progress of reaction here, and here is the energy, right? And if you are taking here, this is the reactant energy. Here is the energy of the reactant. So and this will be the product formed here. And student, this is the energy which will be required by the reactant molecules to get the product formed. So this is the threshold energy, right? If this much energy will be possessed by the reactant, then only the product will be formed. Otherwise, the reactants are not going to get changed into product without external influence. I hope so you're understanding what is external influence. Yes, it is the presence of the catalyst. Now students, the next is the orientation, proper orientation. Now for the effective collision, it's not just collision, but it should be the collision in the right direction. The two reactant molecules, they should face one another in a proper way. Now let us take the example of here. If it is NO2 and NO2, these are two reactant molecules chained, they will just form the product N2O4. Now we're just having a pictorial representation here. And this is NO2 molecule, right? Now if the collision is taking place in this way, right, then only these two molecules are there, right, and the collision is taking place, then only the product is going to form up. Now students, whenever the molecules collide, the old bond are going to break down and new bond will be formed up. Now the orientation should be in such a way that the old bond, right, should facilitate inside the facilitate the formation of the product so that in such a way that the old previous bond breaks and the new bonds are formed. Like the orientation if the orientation of the two molecules, that is the approaching molecule, this is also chance, right? This is N, this is oxygen, the circle is indicating oxygen. In that case, there will be no product formed. So to get the product form, there should be proper orientation, right, students? So to get the product formation, there are two essential conditions. First is the energy barrier and the proper orientation. In both cases, we are going to consider that the collision will be in such a way so that the old bonds break down and the new bonds are being formed. Now we can just sum up that the collision theory, what is state that the first point is that the collision theory states that for the product to get formed, there should be the reactant should collide with one another, and it should be the collision should be the effective one, right? Then the effective collision to get the product formed is only because of the effective collision. The third is that what is the effective collision? It should overcome the energy barrier and should have possess the proper orientation to get the product formed. Now student, the next is that the rate of the reaction. So according to collision frequency, the rate of the reaction is going to depend upon two factors. It is going to depend first upon the collision frequency, and it will depend upon the fraction of the molecules undergoing the effective collision. Again, I'm repeating, according to the collision theory, the rate of the reaction, right, that is R equals to minus dx upon dt, will depend upon the fraction of the molecules possessing the effective collision and, right, and the collision frequency. So, according to collision theory, the rate will be equal to R equals to minus dx upon dt. F is the fraction of molecules showing the effective collision, and Z is the collision frequency. So students, just go through it and just note down the collision theory.